Continue with our discussions about pathogenesis. So we already described subunit B and subunit A, and then the ADP, which involved in ribosylation of EF2, meaning ribosylation you add the ribose of elongation factor 2. Okay, because elongation factor 2 is the one that involves in the inhibition of protein synthesis, which cause the cell death. Okay, so we go back to the diagram. So this is the human cells, and we have the receptors. Again, yung fragment B mo helps the binding of your A with the receptors. And then your A is composed of active subunit cleaves nicotinamide from nicotinamide adenine dinucleotide. So this one, yung elongation factor 2 plus NAD, which involved in protein synthesis. Okay, so once there is a binding of your elongation factor 2, which cleaves with the nicotinamide, which undergoes the ribosylation process. Okay, that is your elongation factor 2, okay, elongation ribosylation, meaning EF2 cleave with your adenosine diphosphate ribose, because it undergoes ribosylation plus nicotinamide, then it will inhibit the protein synthesis in cause cell death in the human cells. So this is how the toxin works, or the pathogenesis, or of course the mechanism of actions of that diphtheria toxin. Again, so your A will, and this one A is ADB ribosylations, okay, in which your active subunit, okay, your subunit A, active subunit, okay, yung elongation factor 2 plus NAD mo, so mag-cleave siya, and then at the same time it undergoes ribosylation process plus yung AF2, or the elongation factor 2 plus nicotinamide, because nicotinamide is coming from the NAD, then it will lead to inhibition of your protein synthesis, causing cell death. Okay, next, so example, these are another diagram. Okay, as a recap, Clostridium diphtheriae, so they have the diphtheria toxin, so this is your fragment P, which helps in the binding with the receptor, and then when it enters, okay, it inactivates yung A, the one that activates the elongation factor 2, okay, which lead to inhibit the protein synthesis, or prevent protein synthesis and cause cell death. Actually, it's not only binding with the receptor. After binding with the receptor, so there will be a endocytosis process also involved. Okay. Next, for biochemical tests, the colonial morphology of Clostridium diphtheria on Tinsdale medium is the most important characteristics in differentiating it from other species of Corynebacteria. So we have urase positive, negative, nitrate positive, or gelatin liquefactions negative. Okay, gelatin liquefactions involve the liquefactions with the protein. So fermentation reactions of various carbohydrates. Okay, gelatin. So Corynebacterium diphtheria sa Tinsdale agar halo, so positive. So this is a black halo. This one almost negative. Okay, so obese or pseudotuberculosis. Sa catalase, all are positive. Urase positive ang ulcerans and ovis, negative for diphtheria. Nitrate test, diphtheria and ovis are positive, negative yung ulcerans. Gelatin, so we have negative diphtheria and ovis, positive for ulcerans. Glucose, all are positive, and sucrose, negative. This one depends upon the reactions, I mean, of ulcerans and ovis. That is why in potential letter V only. Okay, now depends upon the volume. Next, toxicity test, I mean, in vivo toxicity test, which involve the test for the toxin. Okay, the in vivo, which involves already the tissues, so involved animal testing. Okay, from the pure culture of isolate enucleate 10 ml tube, okay, of the what we call